Have you ever had one of those bugs? You know, the one where a variable just mysteriously changes and you have no clue why? Well, the answer might be hiding in a single line of code you've probably written thousands of times. Today, we're going to pull back the curtain on object declaration in Java and see what's really happening in your computer's memory. And trust me, getting this is a total game changer.
All right, take a look at this. Box, my box equals new box. You've typed this or something like it a million times. But what is actually going on under the hood? It looks like one simple, single action, right? Well, it's not. It's actually two very distinct steps happening at once. And understanding those two steps is the absolute key to mastering how Java deals with objects.
So yeah, two steps baked into one line of code. The first part is declaration, and the second part is allocation and assignment. Once you start seeing these as two separate things instead of one, the whole picture of how Java memory works just snaps into place. It becomes so much clearer.
Okay, let's break it down. Step 1, the declaration. This is the very first thing the computer processes. And here is the most important thing to get right now. This step, all by itself, does not create an object at all.
So if we just pull out that first part of the command, we get this: box, my box. All this does is tell Java, hey, I need a variable, I'm going to call it my box, and it's going to hold a reference to a box object someday. That's it.
So what does this little line of code actually get us? Well, it carves out a little space for a variable called myBox, and it makes a rule. This variable can only hold a reference, basically a memory address, for a box object. But right now, it's not pointing to anything. It's just an empty placeholder. Its value is null. Nothing.
Here's a really good way to picture this. Declaring that reference, box, my box, is like going to the city planning office and reserving a plot of land. You get an address, let's say 123 Main Street, but there's no house there yet. It's just an empty lot. You have an address, but no building.
Okay, so we've got our empty plot of land. Now for step 2. This is the fun part, where we actually build the house. This is the active step where something physical gets created in memory.
Now we look at the second half of that original statement. My box equals new box. The magic word here, the real workhorse, is the new keyword. This is the command that actually constructs the box object in memory.
So the new operator is what brings our box object to life. It goes and finds a chunk of available memory in a place called the heap and builds our new object right there. Then, and this is key, it returns the memory address of that brand new object. It gives you the coordinates so you can find it later.
And that is the final piece of the puzzle. That memory address that new gives back, it gets stored in our reference variable, myBox. Our empty plot of land at 123 Main Street now has a house on it, and our myBox variable knows exactly where to find it. The reference finally points to a real, tangible object.
Okay, so now that we've separated those two steps, let's look at a classic situation where this knowledge becomes absolutely critical. This is a super common misconception about assignment that trips up pretty much every developer at some point.
So, check out this code. We create a new box object and have our reference B1 point to it. Simple enough. Then, in the next line, we declare a new reference B2 and set it equal to B1. So, what do you think is happening here?
Seriously, take a second and think about it. We've got two variables, B1 and B2. Does that mean we now have two separate physical box objects sitting in memory? This question is at the very heart of this common mix-up.
And here's the big reveal. A lot of people think that B2 equals B1 makes a fresh copy of the object. It feels intuitive, right? But that is not what happens. The reality is, we still have only one box object in memory. What we have now are two different references, B1 and B2, both pointing to that exact same object. This is the crucial takeaway. When you assign one object reference to another, you are not copying the object. You are only copying the reference. You're just copying the memory address. All you did was create a second signpost that points to the exact same house.
So why is this so important? Because it means that B1 and B2 are pointing to the same object. If you make a change to the object using B2, you're going to see that change when you look at it through B1. The best analogy for this? It's like having two remote controls for one TV. It doesn't matter which remote you use to change the channel on the TV changes.
Now, you might be thinking, wait a minute, simple things like numbers don't work this way. And you're right. Primitive types like int are different. When you say int y equals x, you're actually making a copy of the value. But for objects, which can be huge and complex, copying the whole thing every time would be super inefficient. So Java just copies the reference, the small, simple address. This all boils down to one of the most fundamental distinctions in object-oriented programming, the difference between a class and an object. They sound similar, but they are worlds apart.
A class is the blueprint. It's the set of architectural plans for our house. It defines all the properties and behaviors, but the blueprint itself isn't a house. You can't live in the blueprint. It's just a logical idea that doesn't take up any memory when your program is running.
The object, on the other hand, is the house. It's a physical thing. It's a real instance of that class that we built using the new operator, and it occupies a real chunk of space in your computer's memory. You can have one blueprint, your one box class, and build hundreds of different houses, or objects, from it.
If you only remember one thing from all of this, let it be this. This is the golden rule. When you assign one object reference variable to another, you are not creating a copy of the object. You are only making a copy of the reference. Burn this into your brain. It will save you from so many future headaches, I promise.
So, I'll leave you with this to chew on. The next time you're debugging and you see some data change when you swear it shouldn't have, ask yourself, could it be that I have two different remotes pointing to the very same TV? Because understanding this doesn't just teach you a fun fact about Java, it fundamentally changes how you think about and trace through your code.